Important point. People often make the mistake of getting too attached to their models. That is, having built a model. So, for example, uh, you could imagine Newton, whose model predicted everything that they needed to predict at that point in time, and for a couple of hundred years after that, right? And people may say, well, that is the way reality works. Newton actually found the secret to how nature functions, right? So you can get too attached to models thinking that the model is the real thing. Okay, that would be a mistake. Never mistake the model for the real thing. A model is always an approximation. A model is always wrong. The only question is how useful is the model. Okay, so now let's take a look at how good is a model. Right? What do you mean by a model that is good? We already know that the model is never going to be exact. Okay, now how wrong can a model be and yet be useful? That's the question we want to ask. Okay, so I'm going to consider two models just for illustration purposes. I have a model 1, first model, which happens to be 98% correct for some purpose. We'll see what the purpose is shortly. So I have a model whose accuracy is 98%, and I have another model whose accuracy is 65%. Again, they're for different purposes. Okay, so now we ask a question, which model is better? Right, so obviously you know what's going on. We want to believe that the 98% model is correct. But of course, the very purpose, the very fact that I'm putting this up tells you that, well, that's not going to be the case. Okay, there could be situations in which the 98% model is not good and the 65% model is actually good. Okay, so let's try and understand that. So let's first look at the 98% model. Let's say the 98% model is a model for identifying defective products. In other words, there is a manufacturing process, and out of the manufacturing process comes some products, and what we want to do is to examine the data about those products and then determine is the product defective or not. Okay, obviously we can only examine the model, the product without damaging it. If we damage it and then figure out, meaning if you open it and then say, oh yeah, this is faulty, that's not useful, right? Without opening it, you want to be able to say, is this faulty or not? Because you don't want to destroy it. If it's not faulty, you want to sell it. Okay, so that's the whole point. Okay, so the model is 98% accurate. In other words, for every product, the model is going to say defective, non-defective, defective, non-defective. It's going to keep on saying that. And of course, whenever it says this is defective or this is not defective, that may be correct, it may be wrong. All we are saying is 98% of the time, it is correct. Okay, that looks like a pretty damn accurate model, right? But in a manufacturing process, let's say that we know that historically only 1% of the products that are produced are defective. In fact, 1% itself is too high a defect rate, but I'm just using that as an illustration. Okay, so only 1% of the products are actually defective. So in that case, if 99% of the products are non-defective, all you have to do is to simply treat every product as non-defective. That is, you don't even look at it. You say, okay, every product that's coming out, I'm just going to say it's non-defective. In fact, that's my model. My model is to simply say that every product is non-defective. Okay, now that model will be 99% accurate, right? Because only 1% are going to be defective. 99% of the products are non-defective. My model is saying everything is non-defective. I'm going to be correct 99% of the time. Okay, so this, I can get a 99% accuracy in this scenario, even with that trivial model of saying everything is non-defective. Okay, so my model, which does 98% accuracy, is not a good model at all, right? It's even worse than the most common sense model that I can use for this particular scenario, right? So just because you've got a 98% accuracy, it seems like a fantastic accuracy, it may not be good. Okay, so this is the whole point. The model is only 98% correct. It is actually worse than what we can do with this trivial model. Now let's turn our attention to our 65% model. Okay, so how good is the 65% model? Okay, and this model is about predicting if somebody will be a buyer or not. Okay, let's say that you've got information on a lot of people, and what you want to do is to take a person and based on their characteristics like income, age, gender, education, etc., based on all that, you want to say, is this person going to buy my product or not? That's what the model is all about. And we are saying the model is 65% accurate. In other words, 65% of the predictions the model makes are correct. 35% of the predictions are wrong. Okay, how good is this model? Okay, now let's say that without using any model, we are able to get a 50% correctness rate. Right? Let's say that with no assistance of the model, somebody is being able to say, make a guess and it's right 50% of the time. Let's say that's the scenario. So without a model, we are able to get 50% of the cases right. Okay, which means let's say there are 100 prospects, right? That is, we have identified 100 people who we are saying, I'm predicting that they are going to be buyers, right? Out of those, 50% will be wrong, 50% will be right. So out of those 100 prospects, I will end up getting 50 actual sales because 50 of those people who I say are buyers will actually be buyers, right? So I'm getting 50 people buying the product. Now the model is getting 65% correct. Okay, that means let's say that I pick up 100 prospects based on my model predictions. This time 65% will be correct, not 50%. Okay, and therefore 65 of the prospects will buy. Okay, so what the model is doing is it is providing me a 30% improvement in yield, right? 50 to 65 is a 30% improvement. Okay, so that's what the model is giving me. It's giving me a 30% improvement, which is significant, right? You're actually selling to 15 more people with this model. So you get the profits that you're going to get from those 15 people which were not available earlier. Okay, so this 65% model in this scenario is better than the 98% model of a different scenario. Okay, so that's the important point that we need to look at. Evaluate a model based on what improvement it is able to provide over the status quo, right? So don't get seduced by absolute numbers, absolute performance of a model, either seduced or disappointed by the absolute performance of a model. Instead, what you should really do is to look at, okay, without the model, what am I able to do? With the model, what am I able to do? How much improvement is my model giving me? That's what we want to do. So avoid the trap of absolute performance measures. Instead, compare without model, with model, what benefit is the model giving me? Okay, that's something very important to understand. Okay, another very important thing that I'll point out, when you build a model, in order to evaluate whether a model is a good model or a bad model, try to compute the monetary benefit of the model. Again, in a business context, computing the monetary benefit of a model, that would be useful. So let's take an example, again, a made up example. Let's say that I've got some model which is able to give me a 5% improvement in customer retention. Okay, that is, let's say we've got a company, and in this company, let's say a large company which has, several million customers. Let's say every year the company is losing some 500,000 customers. Again, you're talking about, several 20 million customers. Out of that, 500,000 customers are moving out. Let's say that this is a mobile phone company, and we know that within mobile phones there's always a churn, right? People keep shifting from one provider to another provider. That's what we're talking about here. Okay, let's say 500,000 people are going to be leaving, and you now got a model based on which we are able to produce a 5% improvement in customer retention. Okay, it's just a 5% improvement in customer retention. Okay, so let's try translate that into, which means that if 500,000 people would normally drop off, if you got a 5% improvement in retention, well, you will be able to prevent 25,000 of those 500,000 from leaving your company. Okay, so which means that you're able to retain 25,000 more customers than you would have been able to if you did not have the model. Okay, and let's assume that from every customer you manage to get a revenue of $1,000. Then that means your revenue, this model is contributing $25 million of extra revenue per year. Okay, alternately, instead of calculating revenue, we might calculate profit and say every customer gives us, let's say, $200 in profit. Then you can say that's 25,000 times 200 is the profit that we are going to get, which we would not otherwise have got if the model was not there. Okay, so again, this is just a back of the envelope calculation of trying to quantify the benefits of a model. This is very important in a business context. Another very important thing you have to note is that seemingly small improvements, like a 5% improvement, 5%, what the hell, so small, right? Seemingly small improvements can actually be very significant, especially for large businesses. Okay, that is something you should not scoff at, right? So all you might be looking for in a model is to improve something by 5%, 10%. That's all. You're not looking for the model to be exact and then predict everything correctly. That's not going to happen. Okay, so that is why looking at the monetary benefit, even of small improvements, is important. Okay, in that context, you have to look at, okay, the model is producing only a 5% improvement. But again, we saw how that translates into quite a few dollars. But you also have to look at what the model is going to cost you. Quite often, the model is going to cost you not very much. That is because, after all, to build a model, what do you need? You need data. Okay. Now, that data, most likely, the company will anyway be gathering just for its operations, right? It's not as if to build the model, you have to go and gather some new data. No. In the process of running a business, businesses capture a lot of data just to be able to do their operations. And all we are doing is going and looking at that data and trying to build a model, right? So there may not be a lot of additional expense in terms of data gathering for the model. Of course, you do have an additional expense in terms of the skilled manpower that you need in order to do this model building activity. But that's just people whose salaries you're talking about, right? And in any case, you have to maintain an analytics team for whatever it is. Once the team is there, it's a sunk cost. Whether you build models or don't build models, you're going to still be paying them, right? So in this sense, building predictive models, analytics models, is not a very costly proposition, right? So whatever benefit it yields, 2%, 3%, 5%, is still likely to be a significant savings to the bottom line, of addition to the bottom line of the company. That's the way you have to look at it. You have to say, okay, this model is going to save the company $250,000 and cost the company $20,000. Well, that's still $230,000, which the company did not have. It's good. It may not be big in the overall scheme of things, but it's, four such things, and then you're talking about $1 million. Okay, so that's the way you have to look at it. So that brings us to the end of lesson 1.3. Let's move on to lesson 1.4.